So question 27 asks us to solve three different equations, and we're supposed to explain or justify your steps for part B. So we'll have to look at that closely. So I've written these down below here, so we have plenty of room. So let's do part A first. I'm going to just use an application of the distributive property. So I'll rewrite the left-hand side as 2x plus 2 and then plus 3. And I'm just going to rewrite that again as 2x plus the number 5. Over on the right hand side, I'm going to also apply the distributive property, and that would make this 3x and then minus 3. To each side, I'm going to choose to subtract 2x from each side. Not a requirement, but I prefer to have positive coefficients for x. So I am left with, on the right-hand side, or left-hand side rather, there's the number 5. And on the right-hand side, I'm left with x minus 3. And then finally, I'm just going to add 3 to both sides. So I get this, and that always looks a little goofy, so I usually rewrite it and write that x is the number 8. So x is 8. And, you know, as compelling as that work may or may not look, if it isn't a solution, if it doesn't make this equation true, my work is garbage, and I've got to find, you know, the mistake I made somewhere. So I'm going to plug this in and see if my work is garbage or not. So I'm going to plug in that x is 8, so this will become an 8, and over here I'm going to plug in an 8. Oops, this should be an 8. Interesting. 8. Can't make my pen write an 8. So I'll just write what that is above it. So above that I'll write this is 2 times 9 plus 3. And over here I'm going to have 3 times the number 7, right? Because 8 minus 1 is 7. So on the right hand side you can see we have the number 21. And it absolutely must be 21 on the left hand side for this to be a solution. And yeah, 2 times 9 is 18, 19, 20, 21. 18 plus 3 is 21. So the reason why 8 is a solution has, you know, certainly these steps helped me get to this solution. There's other ways I could have arrived at the solution. There's other steps I could have taken. But the reason why I can state emphatically that the truth of this solution is because when I plug in the value of 8, I end up with truth, right? This is true that the left and the right hand side are equal to each other. So truth always wins. The next one, B. So here's my thinking for this. The thing inside of the absolute value is either going to equal a positive 10, or the thing inside the absolute value has to be a negative 10. And the reason why is the absolute value of positive 10 is 10, which would make a solution here, and the absolute value of negative 10 is 10. So that's a solution because you can see both of those end up being true. So the question that we have is, how do we figure out the values of x that makes that happen? Well, what we do is we're going to break this up into 2 separate equations, and we're looking inside. This thing inside of the absolute value must either be positive 10 or it must be negative 10. So here's the 2 equations that we get. Either 2x plus 1 is the number negative 10, or 2x plus 1 is equal to positive 10. So there's two possibilities here, and that's the trade-off. In order to remove the absolute value symbol, we have to consider both of those conditions. When you have an absolute value that's equal a number, right, we break it up into an or statement. Just like if we have a greater than or equal to, that's an or statement. And when we have the less than or equal to, it becomes an and statement. Anyways, if I solve these, it's the same 2 steps. I'm going to take away 1 from both sides. So on the one hand, I get that 2x equals negative 11. Therefore, x is negative 11 halves. And my other solution, take away 1 from both sides, I get that 2x is equal to 9. And when I divide both sides by 2, I get that x is 9 halves. So those are my solutions, and not because I think I did this right. They're my solutions because when I bring them back up here and I plug them in, right, in the first instance I have the absolute value of 2 times negative 11 halves and then plus 1. And when I evaluate that, 2 times negative 11 halves is negative 11, and negative 11 plus 1 is the absolute value of negative 10, which is 10. So it absolutely checks in that case. And if I bring in my other value of x, which was positive 9 halves, you can see 2 times 9 halves is 9, the absolute, and then 9 plus 1 is 10, and the absolute value of positive 10 is also 10. So these two values, negative 11 halves and positive 9 halves, satisfy this original inequality. And again, I'm finding this by looking inside. I'm looking inside of the absolute value portion of the equation, and from inside I'm writing that either this thing inside is a negative 10 or this thing inside is a positive 10. My final question, part C here, has, if you'll look at it, an interesting statement. And if you notice it, it saves yourself quite a bit of heartache. We have here the absolute value of something. I'm just going to make a simpler example. The absolute value of something equals, say, for example, negative 10. Well, I know this is an impossibility because absolute value is helping me record the distance something is from the origin, or distance something is from 0. So it's impossible for the absolute value to be a negative number. So because I see an absolute value is negative 5.7, I just immediately say that there's no solution here.